Hello, everybody. Hope your day's going well so far. So today we're going to talk about the next type of chi-squared test. Yesterday you guys learned about the chi-squared goodness of fit test, and a big chunk of the work you already learned yesterday. We're going to use a couple things from yesterday and a couple new things with our next type of test called a chi-squared test of homogeneity. The good news is that tomorrow I technically have one more test to teach you, but it's almost exactly like the homogeneity test. So what you learned today is really going to be helpful for tomorrow's notes as well. So let's just jump right in. Our next type of test, chi-squared test of homogeneity. Mrs. Blair was interested in finding the Facebook habits of students at Redwood High School compared to students at Mount Whitney High School. She took a random sample from each high school and recorded the results below. I don't know, maybe I'm out of my time here. Facebook, I don't think you guys use as much anymore. Maybe I should have changed it to Instagram or Snapchat or something, but you know, we'll just go with Facebook. I still use Facebook, but maybe that makes me old. I don't know. So, let's say that I looked at sampling from both schools. And this is what I found, okay? Out of all the students I asked at Redwood, 14 students said they use Facebook not too much. 11 students said maybe once a week. 25 students say at least once a day. And then here's my totals from Mount Whitney. When you actually add those totals, you notice that there were 20 students total that are not on Facebook much. 30 students total that are on it once a week, and 50 students total that check it at least once a day. So that's a total of 100 students that I interviewed. And if you look at each school, basically it shows that I interviewed 50 people at Redwood and 50 people at Mount Whitney. Okay? So these totals are important for us to be able to see what's going on. Now notice I'm comparing these two schools. So you should be realizing that this is very similar to a test that we did last chapter when we would compare two proportions or we would compare two means. In this situation, we're also comparing two different samples to see if they're the same or different. So let's practice something that we should know how to do. Find the marginal distribution of Facebook habits. So remember, marginal distribution is the distribution in the margins. And we're checking at the habits of Facebook. So I'm going to go all the way over here, and I'm going to say, okay, for not much, for marginal distribution, we see that there are 20 people that say not much out of 100. If we look at once per week, you see that there are 30 students that are only on it once a week out of 100. Or if I say one or more times per day, you notice that there are 50 students out of 100. So these give me my percentages, 20%, 30%, and 50%. So those would be our marginal totals in percents. Okay. Now let's look at the conditional distribution of Facebook habits for students from Mount Whitney. So the condition is Mount Whitney. We're only looking at the Mount Whitney students in this case. We're still looking at not much, but we're just looking at the Mount Whitney students. So there were 6 Mount Whitney students out of 50 who say they're not on it much. That's 12%. If I say once per week, once or more per week, there were 19 students out of the 50 that I interviewed, and that was a 38%. Or I could say once or more per day, and there were 25 students out of the 50 that I interviewed that said they check it once or more per day. That's 50%. So these are our percentages purely at Mount Whitney. Now this is one way to look at the data. We could do this for Redwood, and we could compare the percentages between Mount Whitney and Redwood in this conditional distribution aspect. But I want to look at how we could do this with a chi-squared test. So what I'm going to do is, I'm going to say, what if the null hypothesis is that there was no difference between the Facebook habits of students at Redwood versus the students at Mount Whitney? I'm assuming that Redwood students and Mount Whitney students are very, very similar. we're just across 198 from each other, and you're all the same age, so I'm assuming that you guys all are on Facebook about the same. So if that's our null hypothesis, how should we calculate the expected count? So if you think about it, if I have the same sample size for both, we should be expecting the same amount in each category. So let's look at just the expected count of Redwood students for once per week. So that's the second row, first column. So if I scroll up here, we're looking at Redwood students and once per week. So we're looking at these 11 students. How can I calculate the expected amount for these students? Well, if you think about it, if we're expecting Mount Whitney and Redwood to be the same, I'm not going to look at the differences between the 11 and the 19. Instead, I'm going to say there were 30 students total that said once per week. So 30 out of 100, well, that's 30%. That was what we got down here. 30% of students say once per week. So if I got to figure out of the 50, how many would we expect? Basically, I'm saying 30 out of 100 times 50, or 30% of 50, that would give me my expected count, which is 15. So I would expect at Redwood 15 students to be on Facebook once or more per week. And then I'd do the same thing here. I'd say 30 out of 100 students, because I'm assuming there's no difference between the schools. And then if I multiply it by the sample size, 50, it gives me the same thing. And that's again because my sample sizes are the same. So my expected count would be the same for Redwood and Mount Whitney because my sample sizes are the same. Now this may sound kind of confusing. How am I getting these percentages or these numbers? So if it's not quite making sense, I thankfully have a formula for you guys. So down here, you may have wanted to write how we did that. Again, we said 30 out of 100 students, and then we multiplied it by the sample size of 50. That gave us my expected count of 15. But we thankfully have a formula that makes it a little bit easier. Instead of writing it this way, what if I wrote it this way? 30 times 50, and then divide by 100. What you might be noticing with this 30 and 50, let me scroll back up here for a second. 30 is the marginal total for once per week. 50 is the marginal total for RHS. So to find the expected count, if this is seeming too confusing, all you got to think of it as you did the row total times the column total, and then we divide by the grand total. If we do that, it gives us the expected count in just a different way. So that's actually how I'm going to write this formula. To find an expected count when we have a two-way table like this, you're going to take the row total times the column total, and you're going to divide that by the grand total. And again, the reason we're doing this is because if we are comparing the two schools, if the null hypothesis is that the schools are the same, then we have to assume that they're the same. So we take the row total times the column total and divide by the grand total. Okay, so that's how we find the expected count. So it's a little bit different than the goodness of fit, because in the goodness of fit, we don't actually have a two-way table. We're not comparing two samples. We're just comparing our sample to a claim. In this case, we're comparing two different samples to see if they're the same or not. So we have to use a slightly different expected count formula. Now we still have degrees of freedom because it's a chi-square distribution. So here's a new formula. We can't just say number of categories minus 1 because we have two different samples. So what we say is the number of rows minus 1 times the number of columns minus 1. And honestly, I hardly ever use this formula. It's kind of a little bit more work. What I'd have to do up here is I'd have to go up here and count. I've got two rows. Excuse my pop-up. We have two rows and we have three columns. So 2 minus 1 is 1. 3 minus 1 is 2. So 2 times 1 has a degrees of freedom of 2. That's actually what it's going to be here. But what's actually an easier way is, I'm actually going to erase all this for now because there's a way that you could do it by just looking at the table. What I'm going to do here is I am going to chop off, think of it as if it's rows minus 1 and columns minus 1, we're going to take off one row and we're going to take off one column. So we're chopping this row off, we're chopping this column off, or this is the column, this is the row. And then just look at how many numbers you have left. We have 1, 2 numbers left. So that's a degrees of freedom of 2. Now, that might sound a little confusing, so let me show you a couple other examples. I pulled up a couple old two-way tables that we use. This is way back in the beginning of the year. It's a two-way table. Okay, this is 3 columns by 3 rows. If I use that same method I just did, I'm going to chop off a row, or in this case a column, and I'm going to chop off a row. I'm not looking at my totals, I'm just looking at the rows. Well, in this case, if I chopped off a column and I chopped off a row, look, I've got 1, 2, 3, 4 numbers left, so this would have a degrees of freedom of 4. One more quick example, another old two-way table. This is from way back at the beginning of the year. If again, I'm not paying attention to the total columns. If I chop off a column and I chop off a row, because that's row minus 1 times column minus 1, you chop that off and you count how many you got. 1, 2, 3, 4. This one would also be a degrees of freedom of 4. Okay? So that's actually how I like to do it. You would get the same thing using the formula, but I personally like to just look at the formula and go from there. Okay? So we're going to use all this in our 4-step process. Last but not least, you've probably heard me say we're not doing a goodness of fit. So how come we can't use a goodness of fit here? Well, a goodness of fit, if you remember, there's always a claim distribution. Either the categories are all the same, or there's a specific percentage for the categories, or whatever, but there's a claim for a specific amount of categories. In this case, we don't have that. We're comparing 2 samples. So here's what I say. No, we're not comparing one sample distribution to a claimed distribution. What we're doing is we're comparing one sample to another sample. I took a sample at Redwood and I'm comparing it to a sample at Mount Whitney. So because I'm comparing 2 different samples to each other, it's a test of homogeneity. Okay, so I'm going to stop here for now. You guys can move on to the next video for the next example.